So today we're going to cover 6.3, which is over linear functions. We've talked about linear equations, we've talked about functions. So now we're kind of going to put those two ideas together into what is called linear functions. So first, we'll deal with the definition of a linear function. It is a function whose graph is a straight, non-vertical line. A linear function can be written in the form y equals mx plus b. So, a lot of this should be familiar to you. So linear, that's where this first part comes in. Graph whose graph is a straight, non-vertical line. Straight, non-vertical line is linear, meaning it's straight, okay, going on in the same direction. And then a linear function can be written in the form y equals mx plus b. Remember, y equals mx plus b, that is slope-intercept form. We've talked about that as well. Two important parts, m is your slope, b is your y-intercept. So that is something that we will have to remember how to use in this section. So this next slide is just going to tell you a little bit about how this is similar to things we've dealt with in the past. This says this section is very similar to what we worked on in chapter 4. You must remember how to find slope formula. Remember y2 minus y1 over x2 minus x1. Like I've discussed, that's very important to memorize. And use y-intercept. You must be able to do this when using a graph and a table. So we've done it with a graph. This section will deal with a table as well, which will be a little bit new, but nothing too difficult. So let's go ahead and look at an example of this. So I'm going to make my own coordinate plane right here, because this says graph these points and write a linear function that relates y to x. So give me a second, I'm going to draw this coordinate plane. Got something like that. And then I'm going to label them. Again, this won't be perfect, but it will give you an idea of what we're doing. So, first thing it wants us to do is graph those points. So I'll graph each individual point. -2, -6, over to -2 on the x-axis, down to -6. Hopefully by now we know how to graph individual coordinate plane points. So I'm going to graph all of these, 0, -3, 2, 0, and 4, 3. Alright, so those points are points that they wanted us to graph, and they say write a linear function that relates y to x. So remember, the linear function is in the form y equals mx plus b. So this is really just reviewing what we did in 4.6, which was where they gave us the graph and we had to make the equation y equals mx plus b with the two important parts, which I know some students struggle with, so this is good that we're reviewing this again. So, again, the two important parts we need to fill in are m, which stands for slope, and b, which stands for y-intercept. So, y-intercept is very easy to find because the y-intercept, remember, is where these points go through the y-axis. So if I look at this, my y-axis gets intercepted at 0, -3. So that means -3 right there, that is my y-intercept. So the plus b gets replaced with -3. Okay, so then we have to find slope. And again, some students prefer to use like the actual graph, do rise over run. But I think the majority of students like to just use the slope formula. So that's what we're going to use here. So remember, slope formula is y2 minus y1 over x2 minus x1. So they give us 4 different points. you can choose any of the points you want to actually plug in and get your slope. Doesn't matter what combination, kind of like when we did with tables before. You can choose, you just need two of them to find the slope. Most of the time students like to do positive numbers. So I'm going to choose this point and this point. So if I'm choosing these 2 points, I just need to label them first. X comes first, so x1, y1, x2, y2. Once I have them labeled, I'm going to plug each one into this slope formula. My y2 is 3, minus my y1 is 0, over my x2 is 4, minus my x1 is 2. So then we simplify. 3 minus 0, 3, over 4 minus 2, 2. See if that can simplify. 3 over 2 cannot. You don't want to change that to 1 1/2. Most of the time this is how you'll see a slope, as an improper fraction. So 3/2 is my slope. So that gets plugged in for m. So my m is 3/2. So when it says write a linear function that relates y to x, there it is. Y equals negative 3/2. Sorry, y equals 3/2 x minus 3. So for those that struggled in 4.6, this is just a review of that. Remember, what you pick out first is your y-intercept. You pick that by where those points go through the y-axis. So negative 3 is here. And then you find your slope by just choosing 2 points and plugging them into your slope formula. Okay, so now we also need to talk about how to use a table to do this. So it says use the table to write a linear function that relates y to x. So again, first thing you need to think is that this is going to be in y equals mx plus b form. So from a table, you're doing it similarly. Your slope will be found the exact same way as you know before. You pick 2 points, label them, and use your slope formula. With y-intercept, you need to think, when you have a y-intercept, no matter where you're at on that y-axis, you have to think, what is that x value? If you think about it, your x value is always 0. No matter where you are on that y-axis, the x value is always 0. So that means, that gives you an easy hint. And make sure you hear this because this is where students will get confused. Wherever your x is 0, the corresponding y, or the y that goes with it, that is your y-intercept. That's what gets plugged in for b. So x is 0 here, so my y-intercept is 3. So just by looking at that table, I can find out that my y-intercept is 3. That's what I plug in for b. So after that, then I can just use my slope formula to find my slope. So I'm going to choose 2 points out of here. I'll use negative 1, 5 and 0, 3. So negative 1, 5, 0, 3. Again, you can choose any 2 you want. You just have to choose 2. So we're using the slope formula, y2. It keeps popping up, so make sure you memorize that. y2 minus y1 over x2 minus x1. Then we label x1, y1, x2, y2. So my y2 is 3 minus my y1 is 5. My x2 is 0 minus my x1 is negative 1. Make sure you bring the negatives with it. So it should look like that. So then when I simplify this, 3 minus 5, negative 2, over 0 minus negative 1, back-to-back negatives make a positive, so this is really 0 plus 1, which is just 1. And then obviously negative 2 over 1 is just negative 2. So this is my slope, negative 2. So that means in place of m, I'm going to put negative 2. So my linear function that relates y to x is y equals negative 2x plus 3. So that is your answer. So that's how we're going through and breaking down these problems. So I want you to try this one on your own. Go through the same steps we just did. So pause the video, try it on your own, and you can come back and see if you did it correctly. So again, this is the form y equals mx plus b. That's the form that our linear function will be in. We need to fill in our m and our b. To fill in the b, remember b stands for y-intercept. So, y-intercept, remember the tip I gave you on tables. Wherever your x is 0, your y value with it is your y-intercept. So, in this table, my x is 0 right here. So that means my y-intercept is -1. Make sure you get that right, because sometimes you might have it like this, where you have a y that's 0. That doesn't matter for y-intercept. You're looking where the x is 0, whatever the y with it is your y-intercept. So -1 is what I plug in for b. So again, after that, I need to choose 2 points to find my slope. I'll just use 2, 0, and 4, 1. 2, 0, 4, 1. And remember, y2 minus y1 over x2 minus x1. Alright, so then I label x1, y1, x2, y2. So when I plug these into my formula, I'll have 1 minus 0, because y2 is 1, y1 is 0, over my x2 is 4, minus my x1 is 2. Work out the top, 1 minus 0 is 1, 4 minus 2 is 2. I say, can that simplify? 1 over 2 cannot simplify, so that is my slope. So my slope gets plugged in for m, and that will give, once you plug in for your b and your m, that will be your final answer. So your final answer would be y equals 1/2 x minus 1. So make sure you are able to do that and able to use these tables. So this section, more than any other section really, this section is very popular to have word problems on state tests. They like to pull word problems from this a lot. So that's what we're going to go over next, is some word problems with this. So there's a lot of information here, a lot to dive into, but like I said, we need to make sure we are able to do word problems as we go through these types of problems. Here's the tip I'll give you for word problems. Sometimes there's going to be a lot of big words, some big information that you might not know what it is. Don't let that deter you. Don't let that make you think, well, I don't know how to do this. Because all you're looking for are the numbers and what you have to do with those numbers. So, it says you're controlling an unmanned aerial vehicle, UAV, for surveillance. Again, there's a lot of big words in that first sentence. A lot of it you might not even know what it means. That's fine, because that's actually not even important to the actual math of the problem. It's just setting up the scene for you. So you're controlling a UAV for surveillance. The table shows the height, y, in thousands of feet, of the UAV X minutes after you start its descent from cruising altitude. So I want to make sure we understand what's going on. First of all, from cruising altitude means if you're in a plane, cruising altitude is when you're just going straight. Okay, like you've flown up and then you're just going straight. So it says X minutes after you start its descent. Descent is when you go down. So descent from cruising altitude means you're cruising. So you were cruising and then you started to go down. You started to descend. So it says write the linear function that relates y to x, interpret the slope and the y-intercept. Okay, so a lot to break down here. First of all, you wouldn't have needed any of this information to do this first part. Write the linear function that relates y to x. That's what we've been doing. Remember, that's the writing it in the form y equals mx plus b, and you're filling in your m and b. So, just by looking at that table, again, I can find my b, which is my y-intercept, by looking where is the x value? 0. If I look, here's my x value is 0. The y value that goes with it is 65. But remember, this is in thousands of feet, so that means my y is actually 65,000. So, in place of b, I'm going to put 65,000. So, that is what gets plugged in for b. Then for m, remember slope, you're just doing it the same way. You're going to pick out 2 points, find the slope. So, 2 points I'll pick out, 0, 65, 10, 60, y2 minus y1, hopefully you have this down by now, over x2 minus x1, x1, y1, x2, y2. So it'll be 60 minus 65 over 10 minus 0. 60 minus 65 is negative 5. 10 minus 0, 10. Then I have to see if it can reduce, which this one can. Negative 5 over 10 reduces to negative 1 over 2. So there is your slope. That's what we're plugging in for m. Negative 1/2. So, there's your first part. Write the linear function that relates y to x. There's your answer. Y equals negative 1/2 x plus 65,000. So, now, to interpret the slope and y-intercept. So this is a little different than stuff you've done before, but interpret just means to tell what it means. So, to tell what the slope means, you're kind of just going back to the definition of a slope. Remember, definition of a slope is change in y over change in x. So my change in y, or my top number, is negative 1. Okay, so I have negative 1 as my y, 2 as my x. So to put that in terms of this, my y, remember, stands for thousands of feet. So if I have a negative 1 as my y, that means I'm going down. Negative means I'm going down, or descending, 1,000 feet. So what that means is I'm going to, you descend 1,000 feet, but then we have to take into account our change in x. Our change in x is 2, and x is minutes. So that means I'm going to descend 1,000 feet every 2 minutes. Every 2 minutes. So that is what this slope is telling me. Okay, that I'm descending 1,000 feet, that's my top number, every 2 minutes. So that is my slope. M interprets to that. My B is 65,000 feet. To interpret that, remember, we started descending from the cruising altitude. So if we added on 65,000 feet, that means that is our cruising altitude. We were cruising at 65,000 feet, and then we started ascending, and that's where our slope comes into play. So 65,000 feet is our cruising altitude. And I know there's a lot going on in this problem, but it's good to be able to break all this stuff down. So, that answers part A. We got our y equals mx plus b figured out, and then we know that our slope means that we descend 1,000 feet every 2 minutes, and my cruising altitude is my b, or my y-intercept. Alright, so part B says graph the linear function. Okay, so you can just make your own graph here. Doesn't have to be anything great. But then you just want to look at what you're going by. So like we have 0, 10, 20, 30, so I can do 10, 20, 30 on my x. And we go up to 65 on my y, so I can just go by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and then I'll add a 65 in there. Okay, so, and I'm not going to label all those, it goes by 5s. I'm going to save some time just by going through this. So then, everyone in here in this class should know how to graph by now. Use your x first, 0 up to 65, like that. 10 up to 60, like that. 20 up to 55, and 30 up to 50. So you should have something that looks like that, and that makes sense because this is descending slowly, so it's going down. All right, lastly, find the height of the UAV when you stop the descent after 1 hour. So think about this problem a little bit. So I'm going to give you a hint. We're going to use our linear function, okay, that we already found. So part C, we're going to use that linear function of y equals negative 1/2 x plus 65,000. So they say find the height. Height in this problem is y. So we're solving for y. So that means this is what we're trying to find, y. When you stop the descent after 1 hour. An hour is time. And obviously time, or minutes, is x. So first thing we're going to have to do, so basically what we're doing is we're going to plug in the information they give us in for x. And then we're going to solve. So first thing is, 1 hour, hold on, let me make sure okay, so for the problem, sorry, one thing that you do need to, because this will throw it off if not, it's actually, since the actual equation will not be 65,000, it'll actually just be 65, okay? And the reason is, that will help make the math easier, because if it's 65,000, these would have to be 65,000, like the actual number here would. But they tell you it's thousands of feet. So after you solve, then you convert it. Okay? I hope that makes sense. So we leave it at 65 because when 0 is here, it's 65, not 65,000. Okay, so kind of going back to the whole table thing. So this is the equation we use. Y equals negative 1/2 x plus 65. So first thing is, if we're given 1 hour, 1 hour is how many minutes? 60. So 60 minutes is what we're going to plug in for x. So that means in for x here, we're going to plug in 60. So it'll be y equals negative 1/2, and then instead of x, we put 60 plus 65. And then we're going to start working this out. Y equals negative 1/2 times 60 is negative 30. Bring down my plus 65. And then when I work that out, y will equal 35. So this is what the y equals. But then when we interpret it, it says find the height of the UAV when you stop the descent after 1 hour. So that means after 1 hour, your height will be 35,000 feet. So that's what your height will be after you descend for 1 hour. So, like I said, I know there's a lot to break down, a lot of information that was involved there, but like I said, it's very important to know how to use all that information, because you'll see word problems, they pop up quite a bit with linear functions on state tests. So, let's look at a different type that isn't near as in-depth, but something we do need to know how to do. Like I said, this one isn't near as in-depth as the last one, but they also like to ask you questions about comparing linear functions as well. So this says, the earnings Y in dollars of a nighttime employee working X hours are represented by the linear function. y equals 7.5x plus 30. The table shows the earnings of a daytime employee. Which employee has a higher hourly wage? So, a couple ways you can look at this. So first of all, my nighttime employee is y equals 7.5x plus 30. So, if I'm looking at this, we have two important numbers here, 7.5 and 30. So, it says working X hours. So that's important. X hours means X represents the number of hours you work. So, if we're talking about hourly wage, how much you're getting paid per hour, X is being multiplied by 7.5. So like if I work 2 hours, 7.5 times 2 is 15. So that means I get $15. So this number, or your slope, represents your hourly wage. So nighttime employee makes $7.50 per hour. So anytime you have that being multiplied by X, that is your hourly wage, or that's what you're getting paid per hour. This plus 30, it doesn't matter in this problem, but it's good to know like what it might mean. So basically what that's saying is if you add $30, that might just be a bonus that they were giving because they work at nighttime, or people that don't want to work at night, but they give them $30 extra just for coming in at night. So 30 is just added on, but the hourly wage itself is $7.50. So then you can find we're given a table for the daytime employee, and again, if we're trying to find slope, which we are because of that, we're trying to find the change in earnings over the change in time, we're trying to find slope, so we can do it like we always do. Take 2 points from that table, 1, 1250, 2, 25, and we're going to use our slope formula, y2 minus y1 over x2 minus x1. x1, y1, x2, y2. Alright, so this will be 25 minus 1250 over 2 minus 1. Okay, so 25 minus 1250 is 1250. 2 minus 1 is 1. So obviously 1250 over 1 is just 1250. So that means this is my slope. So that means my daytime employee makes $12.50 per hour. So when asked which employee has a higher hourly wage, it would be your daytime employee, because he makes $12.50 per hour. So that's how you're breaking down finding the hourly wage or whenever you're comparing. Most of the time when you're comparing, they're going to want you to compare slopes, and that's what we did here. We compared the hourly wage. So make sure you can pick out which one has a higher slope or higher hourly wage. So last one, I want you to try this one on your own. Pause it for a second, try it. See if you can figure it out. For sake of time, I'm not going to go as in-depth with this one because we're running up on 30 minutes for this video. But it says manager A earns $15 per hour and receives a bonus, $50 bonus. The graph shows earnings of manager B. Which manager has a higher hourly wage? So again, we're just talking about how much they make per hour, which is your slope. So again, the way to find this, they tell you what manager A's is, it's $15 per hour. Manager B, again, we're giving a graph now, so you can just pick out 2 points. There's 1 point. You can find another point that's like right there on the graph. and then you just work it out. So this point is 250. So when I plug those into my formula, y2 minus y1 over x2 minus x1, it'd be 75 minus 50 over 3 minus 2, 25 over 1, which is just 25. So that means manager B earns $25 per hour. So when asked which one has a higher wage, hourly wage, that would be manager B, because manager A only earns $15 per hour. So I know there's a lot of information. If you get confused, obviously you can go back through that video. But making sure you can break down word problems, which I know takes some time, but we definitely need to be able to do that in this section. Thanks.